Hello everyone. Today we re-embarking on a journey across the farthest reaches of existence to answer a question that has haunted philosophers, astronomers, and curious human minds for thousands of years. Does the universe have an end? Let us start with the most basic idea. What do we even mean when we ask if the universe has an end? For most people, the question brings up an image of a giant bubble with a hard outer edge, a place where, if you traveled far enough, you would hit a wall, a void, or something entirely unknown. But the universe is not a room inside a house, and space is not an empty box with boundaries. The universe is everything that exists: all space, all time, all matter, all energy, all stars, planets, galaxies, and every atom in between. When we talk about an end to the universe, we are not talking about a wall in space. We are talking about whether space itself is finite or infinite, whether it has a fixed size or stretches on, without limit, in every direction. This is a vital distinction, and it changes everything about how we approach the question. For centuries, human thinkers assumed the universe was small and static. The ancient Greeks imagined a closed cosmos, with a firmament holding the stars, a finite sphere with Earth at its center. For nearly 2,000 years, this view dominated Western thought, until the telescope changed everything. Galileo's observations revealed that the Milky Way was a band of countless stars, and later, astronomers realized that our sun was just one star among billions in a single galaxy. By the early 1900s, scientists began to grasp the true scale of the cosmos, but they still believed the universe was static, unchanging, and finite. No expansion, no growth, just a fixed collection of stars and galaxies. That all changed in the 1920s, when Edwin Hubble made one of the most important discoveries in the history of science. Hubble, working at the Mount Wilson Observatory, studied the light from distant galaxies and found a shocking pattern. Every single galaxy outside our local group is moving away from us. The farther away a galaxy is, the faster it is racing into the darkness. This was not because galaxies are moving through space, like rockets. It was because space itself is stretching, expanding in all directions, carrying galaxies along with it, like raisins in a rising loaf of bread. This discovery proved that the universe is not static, it is growing, and it has been growing since its beginning. The Big Bang Theory, once a radical idea, became the foundation of modern cosmology. The universe began 13.8 billion years ago as an infinitely dense hot point, and it has been expanding and cooling ever since. This expansion is key to understanding the question of a cosmic end, because it creates a hard limit to what we can ever see, the observable universe. The observable universe is the part of the universe from which light has had enough time to reach Earth since the Big Bang. Light travels at a fixed speed, nearly 300,000 kilometers per second, and even at that incredible pace, it takes time to cross cosmic distances. The oldest light we can detect is the cosmic microwave background radiation, the afterglow of the Big Bang, which has traveled 13.8 billion years to reach us. But because the universe has expanded while that light was traveling, the actual distance to the edge of the observable universe is about 46.5 billion light-years in every direction. This creates a spherical boundary around Earth, called the cosmic horizon, a point beyond which we can never see, no matter how powerful our telescopes become. Light from objects beyond this horizon has not had enough time to reach us, and as the universe expands faster and faster, that light will never reach us at all. Many people mistake this cosmic horizon for the end of the universe, but that is a critical error. The observable universe is just the part of the universe we can see, like the area visible from a boat in the middle of the ocean. The ocean does not end at the horizon. It continues far beyond, and the same is true for the universe. The cosmic horizon is a limit of our perception, not a limit of space itself. So if the observable universe is not the end, what lies beyond it? To answer that, we need to understand the shape of the universe, a property determined by the total amount of matter and energy in existence, as measured by satellites like NASA's SW map and the European Space Agency's Planck Satellite. Cosmologists describe the universe as having one of three possible shapes: flat, closed, or open. A closed universe is curved like the surface of a sphere. If you traveled in a straight line forever, you would eventually loop back to your starting point, meaning the universe is finite, but has no edge, like walking around the Earth without falling off. An open universe is curved like a saddle, stretching infinitely outward with no boundary. A flat universe is exactly balanced between the two, neither curved inward nor outward. and mathematical models show that a flat universe must be infinite in size, extending forever in all directions, with no end whatsoever. After decades of precise measurements, the Planck Satellite confirmed what astronomers had suspected: the universe is flat, to an extraordinary degree of precision, with a margin of error less than 0.4%. This is not a rough estimate. It is one of the most accurate measurements in all of science. A flat universe means that space does not curve back on itself, and it does not curve outward infinitely in a saddle shape. It simply goes on forever. If you could build a spaceship fast enough to travel in a straight line for trillions of years, you would never hit a wall, never reach a boundary, never find a place where space stops. You would just keep passing galaxies, stars, and empty space, endlessly into the infinite dark. But wait, if the universe is expanding, how can it be infinite? This is one of the most confusing parts of cosmic science, but it is simpler than it sounds. An infinite universe can still expand. Expansion does not mean the universe is growing into something else. It means the distance between every single point in space is getting larger, even if space itself has no size limit. Imagine an infinite sheet of graph paper. Every square is getting bigger, but the sheet itself was already infinite and remains infinite. There is no edge to stretch, no boundary to push against, just more space between every object. This is the reality of our flat, infinite universe. It has no end, no outer wall, no final limit. It is endless, eternal in its spatial extent, and constantly expanding. To make this even more mind-blowing, we must consider dark energy, the mysterious, invisible force that drives cosmic expansion. Discovered in 1998 by two teams of astronomers studying distant supernovae, dark energy makes up about 68% of the total energy in the universe, and it is pushing space apart, faster and faster, with every passing second. Unlike gravity, which pulls matter together, dark energy repels space, causing expansion to accelerate over time. This acceleration means that galaxies, beyond our cosmic horizon, will move away from us so quickly that their light will be permanently out of reach. In the far future, trillions of years from now, our local group of galaxies will be the only thing we can see. All other galaxies will have faded beyond the horizon, lost to the infinite expansion of space. But even then, the universe itself will still be infinite, still expanding, still with no end. Some people ask, if the universe is infinite, does that mean everything that can happen is happening somewhere infinitely many times? The math says yes. In an infinite flat universe, there are infinite copies of Earth, infinite copies of you, infinite versions of this moment, scattered across endless space. This is not science fiction. It is a logical consequence of an infinite cosmos, with finite combinations of matter and energy. It is a humbling, awe-inspiring thought that reminds us how small our corner of the universe is, even as the universe itself has no bounds. We must also address the difference between a spatial end and a temporal end. Does the universe have an end in time, even if it has no end in space? The fate of the universe is tied to dark energy. If dark energy remains constant, the universe will expand forever, growing colder and darker, until stars burn out, black holes evaporate, and all matter dissolves into subatomic particles in a state called heat death. If dark energy grows stronger over time, the universe could end in a big rip, where space stretches so fast, it tears apart atoms, planets, stars, and even space-time itself. But even in these scenarios, space itself does not end. It just changes. The infinite universe continues to exist, even in its cold, dark final state. There is no moment when space vanishes, no final second where everything stops existing. For thousands of years, humans have looked to the sky and feared the unknown, wondering if we are trapped in a finite box, with an edge just out of sight. But modern science tells us a different story, one filled with awe and wonder. We live in an infinite, flat, expanding universe, with no spatial end, no boundary, no final limit. The cosmic horizon is a limit of our vision, not a limit of reality. Beyond what we can see, the universe stretches on forever, filled with countless galaxies, stars, and worlds, all part of an endless cosmos that began with the Big Bang and will expand for eternity. This answer changes how we see ourselves and our place in existence. We are tiny, fleeting beings on a small blue planet, but we are part of something infinite, something timeless, something that has no end. The question of whether the universe has an end is no longer a mystery of philosophy. It is a fact of science, proven by telescopes, satellites, and the laws of physics. The universe does not have an end. It is infinite, it is expanding, and it is full of secrets we are only beginning to uncover. Every time we look up at the stars, we are not looking at the edge of everything. We are looking at a tiny window into an endless cosmos that will go on long after we are gone. The pursuit of this question has driven humanity to build telescopes that see back to the dawn of time, to launch satellites that map the universe's shape, and to dream of exploring the stars. It is a question that unites every culture, every generation, every curious mind. And the answer is more beautiful than any myth or story we could have imagined. The universe is endless, boundless, infinite, with no end to discover, no edge to reach, no limit to explore. As we continue to study the cosmos, we will uncover more wonders, more secrets, and more proof that we live in a universe that defies all notions of boundaries and limits. The universe has no end, and that is the greatest cosmic truth of all. Please like, comment, share, and subscribe to the channel.